So in our last lecture, we completed our discussion on 1D collision. Now we'll talk about 2D collision. So what do you mean by 2D collision? So in 1D collision, we had everything happened on one straight line. I mean, on this straight line, there were two balls that were approaching each other, and and velocity of ball 1 was greater than velocity of ball 2, as a result of which the collision happened, and we discussed everything in detail in our last class about the 1D collision. So this is an example of 1D collision. In 2D collision, what happens is, just imagine a ball is here, okay, and another ball is here, and now consider these two balls, they hit each other. Okay, so the ball is approaching, so the first ball is again approaching with the initial velocity v1i, and say the second ball is moving forward with the velocity v2i. Agreed? So now since v1i is greater than v2i, then the ball number 1 collides with ball number 2, but this collision happens in a unique way. So what is that unique way? So so let me draw. This is ball number 2, and now ball number 1 is somewhere around, it hits yeah, it so it hits the ball somewhere around here. So what will happen if the ball number 1 hits the ball number 2 in this manner? So if it hits in this manner, then can you tell me in which direction the reaction force will happen? Okay, forget about reaction force. Can you just tell me intuitively what will happen now? You all know that the ball number 2, okay, the ball number 2 will move in this direction, and the ball number 1 will start moving in this direction after collision. You might have seen this thing happen in a carom board. So when you play that game, this thing happen. But let us try to understand the entire phenomenon in the physics point of view. Okay, what actually happened? So when the ball were approaching each other, everything was okay. They had their own velocity, and when they hit, the ball number 1 gives a gives a force to ball number 2 that increases the velocity of ball number 2, and then due to reaction, ball number 2 gives a reaction force on ball number 1, which is equal and opposite to the first force, and it decreases the velocity of the ball 1. But since the force is acting along this line, okay, then I can actually divide the force, and I can say that force has two component, one upward and one forward component. Agreed? I can do that. So what happens actually? What actually happens? So look at this force. I want you to focus on this particular force. Okay, this particular force has two components, one component in this direction. So consider this is the contact force F. So this part, so if this angle is say theta, then this force has two component, one is F sine theta and another is F cos theta, this side. So F cos theta acts along the left. So can you tell me what is the work of F cos theta? Remember, this force is the force on the ball 1 due to ball 2, and this force here is the force on ball 2. This force is on ball 2 due to what? Due to 1. And this force here is on ball 1 due to 2. Agreed? So what F cos theta does? F cos theta decreases the velocity of 1. And what F sin theta does? F sin theta gives the ball number 1 an upward motion, because F sin theta acts upward. So it will somehow make the ball move in a upward direction. So When you see the final result, look at the final result of ball number 1. You see that ball number 1 is not only moving forward but is also moving upward. Initially ball number 1 here was only moving in straight line motion. It was not moving upward. But now the ball number 1 is moving not only forward but also upward. This is the result of this force that acts in an oblique direction. Similarly, this particular green force, that is the force on 2 due to 1, this force has two components. One is F cos theta, and this F cos theta tries to increase the velocity of ball 2, and there is another force F sin theta, and this F sin theta will try to give the second ball a motion in the downward direction. As a result of which, you see this ball number 2 has two types of motion. One motion is forward and another motion is downward. So it is not only moving forward but also moving downward, as a result of which the final motion is along this particular direction that you can see. Agreed? So this is how the reaction force decides the final motion. Now comes how we can actually tell the equation of motion, how we can predict the velocities. So what are the velocities that we need to predict? Okay, so this ball is now moving in this direction. It must have a velocity v 1f. Agreed? And this ball here, the second ball is moving in this direction. It must have a velocity v2f. Now if this angle is theta, then you see that v1f has two components. So v1f cos theta is responsible for the forward motion of ball number 1, and v1f sin theta is responsible for upward motion of ball number 1. Similarly, this v2f has two components. So if this angle is say theta 2, so I'm talking about different angles. So consider this is angle theta 1, okay, and say this is angle theta 2, okay, assuming that the ball has undergone different angular displacements. So v2f sin theta is responsible for the downward motion of the ball, okay, sin theta 2 is responsible for downward motion of the ball, and there is a forward motion. Look at the red line. Yes, this line, this is the motion of the ball in the forward direction. Who is responsible? The responsible part is actually v1 v2 f cos theta 2. Agreed? So let me zoom in the direction and diagram. Okay, look at the diagram carefully. Now I'll use some colors. Color number yellow will be for diagram number for ball number 1. You see, ball number 1 has two component, v1 f sin theta 1, that makes the ball number 1 move up, and v1 f cos theta 1, that makes the ball move in the forward direction. Now sky color, v2 f cos theta 2, this is responsible for ball number 2 moving in forward direction, and v2f sin theta 2 is responsible for the ball moving in the downward or in the minus y direction. So imagine this is the y direction, okay, and say the lower one is minus y direction. Okay, now so can we write the conservation of momentum? Now how to write the conservation of momentum? Okay, let's see. So let us consider only the momentum conservation along x-axis. Okay, along x-axis, can you tell me what was the initial momentum? So obviously ball number 1 with mass m1 and velocity v1I, this is the momentum, this is the initial momentum of the ball 1. And second, what was the ball? So ball 2 has mass m2 and the velocity of the ball 2 was v2I. So this is the total momentum of the system before collision. Now after collision, since we have to consider only x-axis motion, so this and this will be responsible. So what will be the equation now? So what is the forward motion now after collision? The forward momentum after collision is m1 v1 f cos theta 1. Agreed? You have to agree on this part. It's very easy. It has to be. And what is the forward velocity of the second ball after the collision? It is m2 v2 f cos theta 2. It's as simple as that. So this is the conservation of momentum in x direction. Now let us go to conservation of momentum in y direction. Now initially, is there any motion in the y direction? No, there is no motion in the y direction initially. Everything was moving straight. So what is the total momentum along y direction? It was 0. Now in the final stage, by final stage I mean this stage. What is the motion in y direction? Yes, there is some motion in y direction. One is this, another is this, and they are opposite to each other. So what is the motion of ball 1? So ball 1 has a momentum along y direction as m1 v1 f sine theta 1. Agreed? This is the momentum of the ball 1 in the y direction. Plus, what is the momentum of the ball 2? It is actually m1. So mass into velocity, you know this very clearly, m2. So this is ball number 2 v2 f sine theta 2. Okay, because this is v2f sine theta 2 is the velocity of the ball in y direction. That's why we multiply with m2 and we get the momentum. But there will be a minus sign. Why? The minus sign indicates that these two quantities are in opposite direction. That's why the minus sign. I always said in physics, minus sign represents the direction. So what is actually the momentum conservation in y leads to? It leads to the following equation. It leads to m1 v1 f sine theta 1 is equals to m2 v2 f sine theta 2. Okay, now there is one more thing. This is just conservation of momentum in the x and the y direction because there has been a 2D motion. Now you know how to conserve the energy. You know how to conserve the energy. So what will be the energy conservation? So what is the initial energy of the ball number 1? The initial energy is half m1 v1 I square. This is the kinetic energy of first ball initially. What is the kinetic energy of second ball? Half m2 v2 I square. So these are the energies of the ball. Now can you tell me what is the energy of the first ball after collision? What velocity you should consider? Of course you should consider the total velocities, that is m1 v1 f square. Agreed? You don't take cos theta or sin theta because they are just components. The real velocity is what? The real velocity is v1 f. So total energy is half m1 v1 f square. And what is the velocity energy of the second ball? It is half m2. What is the total velocity of second ball? It is v2f. So v2f square. So in this manner we have conserved the momentum and we have conserved the energy. Now you can play all types of game by combining the momentum equation and the energy equation, and there are various problems related to 2D collision that you can easily solve. But this is the basics of 2D collision. So we'll continue with our basic classical mechanics more in the next lecture.